Hi folks, this lesson we're just going to do one question together. It's going to be on finding the dimensions of a rectangle, and it has to do with questions that take place when you're taking quadratics, which has to do with parabolas. Okay, it's a quadratic word problem, and usually that involves factoring and things like that, and I have videos on all of those details, but in this case I just want to look at this kind of a question in case you're struggling with this kind of a question. And yeah, that way this video won't last forever. So let's start. A rectangle is 3 centimeters longer than it is wide, and it has a diagonal that is 15 centimeters long. Find the dimensions of the rectangle. Okay, so whenever you see a question like this, let's start by drawing a picture. So I'm going to draw a picture up in the corner here. There's our rectangle. It says the rectangle is 3 centimeters longer than it is wide. So if your teacher asks you to, you can say let W equal the width, or let W be the width. I'm just going to skip that step right now. I'm just going to do what's practical right here. And you and I know that W is the width here, okay? You can say all those things over here, but I'm just trying to save time. Now the length is apparently 3 centimeters longer than it is wide. So would you agree with me? We could write W plus 3 right here because, hey, the rectangle is 3 centimeters longer than it is wide. And I'm not writing centimeters here right now because we're just dealing with numbers here. At the end, we'll make sure we talk about centimeters, okay? So the width is 3 centimeters longer than it is wide. So here are our dimensions of this rectangle. And there's one more thing they told us. They said that there is a diagonal, and by the way, a diagonal is from one corner of the rectangle to the other, like this. It says that this is 15 centimeters long. So that's 15. So in this situation here, we're supposed to come up with the dimensions of the rectangle, the exact dimensions. We want numbers here, not letters, or I guess letters in math, they call them variables, okay? So how can we begin to do this? Well, first of all, if we had to know the side lengths of this dimension right here, I'm going to put the W here as well. If you were to focus right now, I'm going to draw this in green. If you were to focus just on, actually no, let's draw it in red. Look at this triangle right here. Would you agree with me? This is a 90-degree triangle. And we have a situation here where in the past, and I have videos on this, in the past we know something called the Pythagorean Theorem. Okay, it looks something like this. C squared is equal to A squared plus B squared. What that means is if you multiply one of the sides by itself and the other side by itself, if you add those up, you will end up with the square of the hypotenuse, which is this long side right here, the 15. So if we were to use this to help us with the dimensions here, we can start moving forward with answering this question. So I'm going to take the 15 and put it where the hypotenuse is, right here. And apparently that equals this squared plus this squared. So W squared, that's this part here, okay, plus this squared, which is, I'm going to put it in brackets to make it easier to see that it's like together. So we have this side squared plus this side squared will equal 15 squared. Okay? At this point, we could, I don't know, we can put everything together. Let's see here. 15 squared we know is 225. If we were to multiply that on a calculator, we have W squared. And over here we have W plus 3 squared. That's like saying W plus 3 multiplied by W plus 3. Okay? You can stop or push pause and multiply this all out right now if you like. But what I'm going to do is quickly write out what you get as an answer. You end up getting W squared plus 6W plus 9. Okay, so you end up getting that. And then what you do is you put all of this together. So put any like terms together. So I'm going to bring the 225 over. I'm going to bring this 225 and subtract it from here and bring it over here. So let's put the two w squareds together as well. Those are called like terms. So we have 2w squared. We have plus 6w. And then subtract 225 from both sides. So 9 minus 225 would be negative or minus 216. Okay? And at this point, we would have to factor this thing, because what we're trying to find out is what w is. What is w? And then we will know the width. And we know the length is going to be just the width plus 3. So if we had to factor this thing, well, we could just try and factor it, and then after that, if it doesn't work to factor it normally, we could use what's called the quadratic formula. But in this case, I believe this question, we don't need the quadratic formula. It's actually going to factor nicely for us. Now, the very first step in factoring is you look to see, is there a common factor amongst all of these that we could take out? And each one of these numbers is even. Can you see that? So what we're going to do is divide each one of these numbers by 2. So if we divide every one of these terms by 2, we end up getting w squared. 6 divided by 2 is 3, so we get 3 right here. And 216 divided by 2, if you think about that for a second, it's 108. And now we can look at this. Leave the 2 alone. We can look at this and say, is there something that will multiply to make 108, not just 108, but negative 108, and that would add up to make 3? And you can push pause once again and think about it for a while, and if you do, you should come up with these two numbers. And by the way, the w goes here and here. And this is all about factoring trinomials, which I have lots of videos about, okay? In case you want to go back and refresh how to do this factoring that I'm doing here. But in this video here, we're just going to quickly say there are two numbers that multiply to make negative 108 and add up to make 3. And those two numbers are negative 9 and 12. Try it if you don't believe me. Just take a calculator and go negative 9 times 12. You should get negative 108. If you add these two up, you get 3. So this works out really nicely. Now, when you do math like this, when you do a real life situation, when we're talking about a rectangle, there are two factors that we get. There are two zeros that we get. So this parabola cuts through at two different spots. It cuts through not at negative 9, but positive 9. And it cuts through not at 12, but at negative 12. So it cuts through at negative 12 and positive 9, right here and here. This parabola is, and if we look up here, we can see it's facing upwards because it's positive. So it's going like this. And we, in this situation here, we don't need the answer that is negative because we are talking about a distance. And in math and in real life, a negative, you can't talk about negatives with regards to distance. Distance is always positive. So we know that 9 is going to be what w is. W is going to equal 9. And the length, we know that the length is 3 more than the width. So 9 plus 3 is 12. And that is a fluke. This 12 right here has nothing to do with this 12 right here, in case that's confusing to you. Now let's see if that makes sense. We have a triangle right here. Apparently this is 9, and apparently this is 9, and this is 12. If we were to use the Pythagorean Theorem, if we went 9 squared plus 12 squared, well, that would be 81 plus 12 times 12 is 144. And if you get your trusty calculator out, 144 plus 81 is 225. If you take the square root of 225, that should give us the hypotenuse of 15, just to verify our answer. So I'll take the square root, and it's 15, sure enough. That helps us be really happy right now because it means that all of this hard work we did to get this answer paid off. And so the dimensions of the rectangle for the final answer, you would say with a sentence, because it is a sentence question, to make your math teacher really happy, you'd say, the width is 9 centimeters and the length is 12 centimeters. And you'd say, thank you very much. Give me another question. I'm ready for it. And that is how you solve a question like this, by factoring using quadratics. Okay, and we had to use our knowledge from the past of the Pythagorean theorem as well. Hopefully that helps you out with if you have a similar type of question sitting in front of you. There's so many different kinds of questions out there, so I apologize if this didn't help you. But every little bit you learn is going to help you, give you hope for future questions that are sometimes confusing. Hope you have a good day. Bye.